Hello everyone, I'm Jie Zhang from UCL. Welcome to my talk about our TSE work, a study of bug resolution characteristics in popular programming languages. So there are different languages and with different features. It's important for us to learn more about these languages because developers, they spend a lot of time fighting with bugs. According to our survey, over half of developers, they would consider bug resolution effort as a factor for language selection. For researchers, we fight with bugs as well. We do software testing, we do automatic program repair. It's important for us to know which languages they have more problems and challenges that deserve more research effort. So do we know the languages well? I'm afraid not. There has been a lot of debate over this. Take Python as an example. Some people think that bugs in Python, they're easy to handle because its code is very easy to read and understand. Some other people think that the lack of stack typing in Python 2 would lead to more bug handling effort. So in this work, we would like to do something to shed light on this great debate. So we want to know, for projects constructed from popular programming languages, which sets of projects they have more bug resolution efforts. So I want to strengthen that what we are doing here is correlation analysis, not causal analysis. So to get the answer to this question, we conduct a large-scale study using the data that we mined from GitHub projects. So for this kind of large-scale study, we really need to take the experimental design process very, very carefully because there could be a lot of threats that would affect the results. And we put a lot of efforts in this, trying to get more reliable results. For example, we use multiple effort measurements to measure the bug resolution effort. We care about the size of the patches in terms of the lines of code and also the number of files that change. We also care about the bug resolution time. We use different statistical analysis approaches because we want different approaches to mutually validate each other. We'll then use their mutual conclusions, their shared conclusions as the final conclusions. We also conduct different levels of analysis. We have project level analysis, which means each analysis subject is a project. We also have the commit level analysis, where each analysis subject is a commit. So we choose 10 most popular programming languages according to language rankings. And we classify them into different types to also study the influence of the differences among different languages categories. So when we try to get the buggy commits, an interesting finding is that previously widely used keywords such as issue, mistake, and fault would just have 30% precision. So that's why in this paper, we only use fix and bug to get the buggy commits, which means that when a buggy commit message contains both fix and bug, we will regard this commit as a buggy commit. And we found that this method will have 95% precision. So when we try to get the bug resolution time, we use the issue reports. So we designed 4 research questions to evaluate, to get the results. And due to time limit, I will just introduce the first 2. So the first research question, we would like to know the differences of bug resolution efforts among different languages. So it's interesting to find out that when we focus on the bug resolution size, we can see that Java and the C#, they always rank first among all the languages. So which means in our corpus, projects written in Java and C#, they have notably higher bug resolution size than the other languages, which is not surprising because we all know that Java and C#, they are quite verbose. We also note that for Ruby and Objective-C, they also rank first when we check the bug resolution time among when using different analysis approaches. So we get the conclusion that projects written in Ruby and Objective-C in our corpus, they consume notably higher bug resolution time than the other languages. The second research question, we compare the bug resolution characteristics among different language categories. So we compare static typing and dynamic typing, and also weak typing and strong typing. And we also get shared conclusions with different analysis approaches. So we found that strongly and statically typed languages in our corpus have bug resolutions that tend to occupy more lines and files. But dynamically typed programs, they tend to consume longer bug resolution time. Sorry that due to time limit, I have to conclude now. So here are some interesting implications. So for researchers, when we do automatic program repair, different languages, they may need different sizes of the patches. And for languages that correlate with more bug resolution time, such as Ruby, they require more significant resources to maintain. So this means that they deserve more research support in testing and automatic bug repair. Okay, thank you very much for your attention. Please feel free to email me your comments, thoughts, and suggestions. Looking forward to having more discussions with you. Thank you, bye.